Next one. Okay, we're going to need to use exponential tables of the parent graph with the base that's in the equation of these logarithms. We're going to use, if I notice this is a base 2 in this logarithm, if this is a base 2, I'm going to look at the parent function of the inverse, 2 to the x, and find its table. Because I can plug that in my calculator. So I use the parent function of the inverse of that log, and I'm going to switch the inputs and outputs to find the logarithms points. Same directions, graph the function and state the domain and range. And we're going to have log base 1/2 of x plus 4 as our function. I look at the base in the equation, and that's the base to the x power that I'm going to look at to get my inputs and outputs. If I switch the inputs and outputs, I get the function log base 1/2 of x. So when you switch the x and the y's, you only get this piece of our puzzle so far. That plus 4 is taking all of these outputs and adding 4 to them. I don't do anything to the inputs. It's just the outputs that'll change. So notice how my new outputs, instead of -3, I'm now at a 1. Instead of -2, I'm now at a +2, and so on. These will become my points for my function that I'll graph. Let's see what it looks like as a graph. In the next slide, if we switch, or if exponential graphs undo logarithmic graphs, and the inputs and outputs all switch, then that means the domain and range words will be switched. And instead of this y equals to a number, it'll be x equals a number. So let's see how it all switches. Domain will be restricted using an asymptote as our guide, and it's got to be x equals a number, so it's going to be a vertical line. And range will now be all real numbers. We're going to see how this function's domain and range changes. Notice how we said the domain is going to have a restriction. The domain is going to have an asymptote that is a vertical line. So if I look back at my tables, my inputs should have something that all has the same. And this graph is getting closer and closer to having an input of 0. So the asymptote now becomes the vertical line x equals 0. Our domain will be using that as a guide. So this graph is approaching x equals 0. Using that as a guide, domain is to the right of that asymptote 0. So how I write it is x is greater than 0. So trust me that those are the inputs and outputs that we would be getting. 0.037, 037, 037 is actually 1/27th. 0.111 repeating is like a 9th. 0.33333 repeating is a 1/3. Switch the x and y coordinates. When you have an input plus 1 inside, you actually have to take your inputs and subtract 1. to keep those nice integer outputs. So if I'm adding a number within parentheses, I'm going to be subtracting the number from the inputs. The graph, and then we're going to state, domain, and range. The asymptote is the vertical line, x equals -1. So then the domain is affected by that. If I look at the asymptote, x equals -1, the image is to the right of it. So to symbolize being to the right, the domain is greater than -1. And last but not least, with that range, you can get any real number for the outputs. The range will be anywhere.